Hello, my name is Robert Smith, and I'm with New River Community College. And today we're asking the question, how do you determine whether one species can reduce another species under standard conditions? In this case, we're asked whether iron can reduce nickel under standard conditions. And to answer this, you'll need to refer to a standard reduction potential table, or you can refer to it if you just happen to have one available, as you should in your book Chemistry by Chang, or you can look one up online. And in the standard reduction table, you'll have a list of half reactions that are written in their reduction form. In this case, we can look at nickel. Nickel would be Ni2 plus goes to Ni solid plus 2 electrons. It's a charge balanced reduction equation. And in those, in that standard reduction potential table, you'll have the standard potential for that half reaction. And to determine whether something is can reduce another, one species can reduce another species, you have to look at where these potentials lie. And it's always in terms of the reduction potential, the ability to reduce a species will be written in such a way that it is decreasing as the E cell increases. So something that is very negative will be able to reduce something that is very positive. So in this case, if you were to look at your standard reduction potential table, you have Ni2 plus yields nickel solid plus 2 electrons, and that will be between Fe2 plus yields yields Fe solid plus 2 electrons, and Fe3 plus will be much higher up, meaning that this is potential the potential will be increasing as we go up. So this will be fairly negative, whereas this will be much more positive. In fact, they are negative and positive. So this would yield Fe solid plus 3 electrons. So we're not even going to write down what the potentials actually are. We're just going to recognize that by reading our standard reduction potential table, we can determine what species can reduce other species, what species can't. So in this case, because of the order in which it occurs, the iron 2 plus will be able to reduce nickel 2 plus, and nickel 2 plus can reduce iron 3 plus, but iron 3 cannot reduce nickel. And we can actually write out the equations for this. So because this is the iron 2 plus will be reducing nickel 2 plus, and in fact, what will happen is that iron solid, we will have to rewrite it in the oxidation fashion, the oxidation direction. So Fe2 plus 2 electrons. And then we would add that to the nickel 2 plus 2 electrons yields nickel solid. So the overall reaction, because the electrons would cancel, would be Fe solid plus nickel plus 2 plus would yield iron 2 plus nickel solid. So iron can reduce nickel in the form to create iron 2 plus. Iron can't do it when it's going toward iron 3 plus. So if you're trying to reduce nickel using iron, it'll be to the it'll yield an iron 2 plus, not an iron 3 plus. Conversely, we could look at the iron 3 plus case real quick. In that case, what you would start off with is nickel solid. And it wouldn't just be one nickel solid, it would be 3 nickel solids plus 2 iron 3 pluses would yield 3 nickel 2 plus 2 irons. So you could do it in that fashion where nickel can actually reduce iron, but ultimately, if we're looking at whether or not iron can reduce nickel, it can. It only yields an iron 2 plus as the product, along with the solid nickel. It won't yield it won't work if you're dealing with iron 3 plus.